Hey everybody, I'm Andrew.
I'm Kevin.
And this is episode 6 of the Baker Nicholas Show.
And we're just going to talk to you guys again about our tutoring experiences this week. And I think the way we're going to do is we're each going to talk about just one situation we helped a kid out with, like each take a turn just talking about our problems that we worked with. And I guess I'll go first. And I don't know if you guys want to take a look at this. But it was a problem that I helped the student out with, and it was solving for x by U substitution. And usually U substitution goes with integration, I guess if you probably know that. But this wasn't an integration problem, but it was just it was asking to solve for x by substituting u in for the exponential e to the x. So this is the original equation right here. So we have 3e to the negative 2x plus 2e to the negative x equals 1. So to substitute a u equals e to the x in, when you plug it in for e to the negative 2x, because there's 2, like the extra exponent 2, this is going to be multiplied by this exponent. So when you sub it in, like u represents e to the x, so all you need to keep is that negative 2 component from the original function. And then the same thing over here, you just need to keep this negative 1, so you would get negative x for the e to the x. So once you have 3u to the negative 2 and 2u to the negative 1, a variable raised to a negative exponent is the same, or it can be written the same as putting the variable to the exponent in the denominator with a positive exponent. So now that we have 3 over u squared plus 2 over u equals 1, then we can have like terms on the like denominators, common denominators, excuse me. And then so this term, the second term, just needs an extra u, so that we have a u squared on the bottom, and then we can combine them so that we have 3 plus 2u over u squared equals 1, and then you multiply by 1 over u squared on both sides, or is it u squared over u squared on both sides, so that you're multiplying by 1. And then that'll get you to 3 plus 2u equals u squared, and then from there you just have a polynomial, u squared minus 2u minus 3 equals 0, so you can factor that to negative 3 and a positive 1. And then after you factor that, you have u minus 3, u plus 1 equals 0, and you have u equals negative 1 and u equals 3, so you substitute in back your e to the x for u equals negative 1. So you have e to the x equals negative 1. And you can take the natural log of both sides, since natural log is the inverse of e to the x. So when you take natural log of both sides, natural log of e to the x, they just cancel each other out, so you're left with x. And then natural log of negative 1 on the other side. But property of natural log is if you take the natural log of a negative number that is undefined, so this can't be our answer. So then we have our other side is u equals 3, so we have e to the x equals 3. You take the natural log of both sides, and so you get x equals the natural log of 3, and then that's the answer you get. So that's one way to just, you're solving for x by substitution of u. So it's like technically u substitution, I guess, because you're using your variable as u, but it's not the, I guess, u substitution which most mathematicians think about when you do integration and integration by parts. But I guess he'll probably be getting that later. The kid was working, this was like an SAT prep work, so that's where he got the problem from. So once I got him just to rewrite the equation, he was able to do most of the work himself. I just had to help him out with just being able to substitute u in for the variables.
Nice. So in our first period class, we've been kind of struggling with, just student involvement with everything. And so I was really excited this week that I had a kid ask for help. And so we were helping, he needed help with systems of linear equations.
So I could like to.
Yeah. We had systems of linear equations. And so the problem that I'm going to show and that I helped him with is Alright, so we have 3x plus 2y equals 7, and then 2x minus 3y equals 4. And so, you know, our goal is to solve for x and y, right? And, not and y, or any y. Solve for x and y. Alright, so as the student had just recently learned the method of canceling out. So canceling out means we're going to multiply either one or both of the equations by a scalar, a constant value, to see if we can cancel out one variable, and then that will just leave us as one variable, and we solve for that. And then we use that value of the variable to plug in and solve for the other variable. Alright, so look at this problem. We can't multiply one equation by a certain scalar because, you know, these values are not multiples of each other. Are not, yeah, like 2 doesn't go into 3 and 2 doesn't go into 3, so we can't do that. So we're going to multiply each equation by a certain scalar, and our first goal is to cancel out the x variable. So to cancel out the x variable, we're going to find the least common multiple of 2 and 3. And the least common multiple of 2 and 3 is 6. So we're going to multiply this equation by 3 and multiply this equation by 2. So therefore we get 6x and 6x on both sides. So we get 6x plus 4y equals 14, because the 2 is distributed to each term. And then we get 6x minus 9y equals 12. Right? So now we have 6x plus 4y equals 14 and 6x minus 9y equals 12. So now we can subtract the two equations, and the 6x's will cancel out. So if we subtract, we get 6 minus 6 is just 0. A 4y minus a negative 9y is positive 13y. And then we get 14 minus 12 is 2. So now we just have a simple, you know, calculation of, you know, we divide both sides by 13. 13, sorry. And we get y equals 2/13. You know, not as neat as I would have liked it to be, but it's alright. So now we have our variable y. We can choose this value and plug it into either of this equation, or we can plug it into this equation. So I'll choose the top one. So we do 3x plus 2 over 2/13 equals 7, right? So we get 3x plus 4 over 13 equals 39, 78, yeah, so it equals 91/13. Alright, so I changed the 7 to, you know, in terms of just 13ths, and so 91/13 is the same as 7. And I'll change my variable 3x into 13ths too. So we have 39/13x plus 4/13 equals 91/13. So you subtract. So our whole goal is to get x by itself, right? So we subtract 4 over 13 over. So we get 39/13x equals 87/13. So now we can multiply by the reciprocal on both sides, and we get 13 over 39 times 87 over 13, so we get x equals, the 13's cancel out, so we just get 87 over 39, which equals 29 over 13. So there we have it. That's how we do systems of linear equations, is that we have, you know, our whole goal is to solve for x and y that satisfies each equation. So first we solve for a certain variable, it could be x or y, and then we solve for another variable. So we have x equals 29/13 and y equals 2/13. So yeah, Kevin and I didn't really, you know, we kind of had like a low-key week, but some good things about this week were we just had well, I feel like we kind of alternate just of how much work I think more some days, you know, he works with more kids and I work with more kids.
Yeah.
So it's been a good balance. I think the kids are comfortable with working with both of us. So.
Yeah, I think so. I mean, they've definitely like opened up to us. Like they want help in more than just math. Like I've helped kids out with like English homework, and this past week that we were in there, I helped like 2 kids out with their physics homework. So, you know, it's like, I don't know, like you said, it's a nice balance. Like they like to work with us. Like they're open to us, and we're definitely there to help. So.
I think
just looking forward to next week, I guess.
Yeah, I think that about wraps it up for episode 6 of Baker Nichols Show.
Thank you.
All right, see you guys.